So we map the mean high water boundary, and then we add sea level on top of that. So you could call that a linear superposition method or a modified bathtub, but it's not true bathtub, where true bathtub would be the same value applied to the entire region of the entire DEM. We're using variable values based on a modeled tidal surface. I hope that isn't too confusing.
Okay, let's see, and he said, okay, that makes sense, a series of smaller bathtubs.
Kind of, sort of, yeah.
Let's see, and on the marsh, another question is, on the marsh impacts tab, can marsh become open water if entirely inundated? Just looked at a few examples in worst case scenario, 6-foot sea level rise, no accretion, and it appears that marsh will only turn to saltwater marsh but not open water.
I think it depends on the region you're looking at. There are some rule sets in there that I didn't mention, and that is that if there's medium to high density development, we don't let it encroach into those areas because we're assuming that we're not going to abandon them. And a lot of it has to do with the, there are some places where the LiDAR, it's always an issue. If you don't have tidally controlled LiDAR or elevation data collection, in some cases you miss, if you collect something at high elevations underwater, you don't capture those elevations, so it looks like it's open water to begin with. So if that's the case, then some of the marsh migration model things get kind of screwy because you're already showing it as open water and there's actually marsh there. So and there's not much you can do about that. That's really kind of highlights the importance of collecting elevation data. If you're trying to model the marsh, you got to collect